Hi guys, in this video I'm gonna show you how to play simple sounds using single channel piezo speaker in embedded devices in Arduino. And to play a sound you have a function called tone. It's actually a tone generator, but if you put this generated tone obviously on a speaker it will play sound. And the syntax is pin, frequency and duration. Obviously the pin is a pin on the board, a digital pin, which has tilde in front of it. It's that squiggly symbol in front of, for example, D2 and D3. And we will use one of these to play a sound on a speaker. And this is a speaker. It's a piezo speaker, single channel that has two pins. The one is ground, the other one is connected to the digital output obviously, and the orientation is irrelevant because if you swap these two it means just that the audio signal is going to flip, but you cannot hear that. It's the same sine wave, just flipped a bit. And yeah, let's do the demo. Here I have a setup. Let's create a constant for the pin, const int pin speaker equals to, let's say, D2, and in the setup I will use pin mode pin speaker, and it's going to be output, and in the loop we have tone. You can see the function tone, and the pin is going to be pin speaker. The frequency, let's say, I think the tone A is 440 Hertz, 440, and the duration is 1 second. Because this function doesn't pause the execution, it executes immediately, we need to have some delay. And let's have delay of 2000 milliseconds in this case. And that's it for the code. Let's head back here to the board. I'm gonna disconnect the board and connect the speaker. As I mentioned before, the orientation is irrelevant. Just make sure that you hit the hole where the pin is for the speaker. And I have this one on the ground. And let's choose, I'm gonna just change position so it's more visible, and this one is going to be on a D2. It's this pin here. Now you can connect the board and cloud flash. It's being flashed, and you can actually hear. Give it some time. Now I need to reflash again. Cloud flash. There are some beeps because the board was checking the pins. And that's it. I will bring this closer to the mic. This is tone A each second. So how this works? I will just disconnect so it doesn't make any noise. Here, the third parameter of the tone is actually duration of played tone, because this doesn't pause the execution, it executes immediately. That's why we need this delay. And because this doesn't last any time, virtually any time, the first second of this delay here is going to be at this second from the tone, and after 1 second the tone ends, and there is still one more second of this delay, and that's why we have tone each second, like this. I'm gonna show you another demo while to make this video more interesting. There is a code here which plays a song, and I will flash this one and I'm gonna show it, put it on a mic. Sorry, that's a previous code. Give it some time for the flash there. And that was Game of Thrones intro song. I am so not into the music. I have no idea how this works, the tones and so on. I don't have ear for it. But let's check the code, how this works. First, by the way, I got help from my colleague, which is a kind of musician. First, I have two lists here, two arrays. The first one is the notes, and if you know how the notes work, you probably know what is E, A, capital A, small a, and so on. I have no idea. And those are notes, and those are beats, and the beats are responding to each note. So this is 6 beats, and the rhythm, the tempo for this is 140 probably milliseconds for each single beat. And so this means that the first note is going to last 6 times 140 milliseconds. And in the setup, we also have this speaker pin, and the length of the song is 37 notes. So this is probably 37 characters here. Yeah, it says 38 selected because so this is 37, and also the beats are 37, and the space is the pause, obviously. And in the setup, because this obviously executes only during the setup, the loop is empty, it doesn't do anything. Here it's very simple. Here in the for loop, I'm looping through all the notes, goes from the 0 to song length, and I'm calculating the duration by taking the beat at the specific index of a note. So we have a note and beat, and multiply this by tempo. It's actually a rhythm, and this duration is obviously in milliseconds. And I'm checking if the note is empty space at the index. So you can see that there is some spaces here. It's the pause, rest here, and I'm delaying this without playing any note. And here, if there is no break, I am playing a tone on a specific frequency for duration, calculated duration of time. And this frequency is a function that is being implemented down here. By the way, we have a tiny break. It's if we divide 140 by 10, it's 14 milliseconds between nodes, so it sounds more natural. And I was saying the frequency is being implemented here. So the input to this function is character A, B, C, D, and so on. And it outputs the number of hertz for the frequency. So for example, if the note is, let's say, big A here, it should return frequency of 220 hertz. If it's small, oh, I made a mistake. Oh, no, it's okay. So the A, small a, is 440 hertz. And what it does, it just iterates through all the names here. This is array of names, finds the corresponding node as a parameter, checks the index, and returns the index location of the frequency. And it's very simple. and that's how you play some music. The music is obviously very simple, single tone, and obviously not loud enough. However, it's good for simple projects like this. I hope you learned something and see you next video.